Guys, in this video we are going to see how to write vectors in component form. Now let's look at some examples. Let's say we have a 100 Newton force acting on the x direction. Since we have straight horizontal, we can directly write this vector in component form as 100i, because there's no j component, because if we have some vertical, like vertical shift, for example, if we have some angle, we can write a vertical component. But if it's straight vertical, it's the vertical component is going to be 0j, so we don't have to write that one. This is going to be just 100i, so we can write f is equal to 100i. Okay, and let's say we have a force acting on the vertical component, let's say acting downward, 200 Newton. So if it acting downward, we can write negative 200, and this is in the vertical component, so this is going to be j. Okay, we don't have horizontal component, so we don't have any I. We have 0i, we don't have to write that one. Okay, now let's look at some example with angles. So let's say we have a force acting in this direction, 500 Newton, that is making angle with the horizontal, making 60 degree with the horizontal. Okay, so the y component for this one is going to be like this. This is fy, and the x component is going to be this one. Okay, this is our x component, this is our y component, and you can see if we take cos 60 and sin 60, cos 60 is going to be adjacent over hypotenuse, so fx is the adjacent, right? Okay, let's write the cos 60. Cos 60 is equal to adjacent over hypotenuse. Adjacent is fx over hypotenuse is 500, so we can write fx as 500 cos 60, and that's going to give us 250 Newton. Okay, this is our x component. Now for the y component, if we take sin 60, sin 60 is going to be opposite over hypotenuse. Opposite is fy divided by hypotenuse, that is 500. Therefore fy is going to be equal to 500 sin 60, and that's going to give us 500 sin 60 is equivalent to 433 Newton. So this is our xy component. So we can write our force as 250, and this is in the x component, so this is going to be I, and here we have y component, that is 433, and that is positive, so this is going to be plus 433j, and that's it. Now let's look at another example. Let's say we have a force acting in this direction, and that is the force is 100 Newton, and that is below the horizontal 30 degree below the horizontal. This is going to be our fy, and here we are going to have the fx. Okay, again, whenever we have this kind of thing, we can always use the same thing. We can use fx is equal to f cos theta, and fy is equal to f sin theta. Here we are going to do the same thing. Fx is going to be equivalent to f is 100 cos theta cos 30. 100 cos 30 is going to give us 86.6 degree, and the direction is in the positive x-axis, so this is going to be positive. This is not angle, this is Newton, right? So this is 86.6, and that's positive Newton. But for the y component, we have to put sin 30, but the direction is negative, because you can see if we draw the coordinates. Okay, let's draw the graph first. For this one, we have y component positive, right? Y component positive. For this side, we have the force in this side, so the y component is going to be negative. So that's why we are going to get a negative for y component. Here fy is going to be equivalent to 100 sin 30. Sin 30 is equal to half, so we are going to have 50, but we have to add a negative sign because of the direction, because it's downward. So this is going to be negative 50 in the y direction. So the component form for this one is going to be f is equal to 86.6 in the I direction plus, actually minus this minus 50 in the j direction, and that's going to be the component form for this vector. Okay, now let's look at an example in 3D. Okay, let's get rid of this one. Okay, let's get rid of these parts. Okay, now we are going to look at an example in 3D. Okay, let's say we have a vector. Let's write our xyz component. Okay, let's say this is our z component, this is our y component, and this is our x component. Okay, so this is our z component, and this is y component, and this is x component. Let's say we have a vector in this direction, and that is making angle with the xy plane. This is xy plane making angle with the xy plane 50 degree, 50 degree, and making angle with the, let's call this one x. Let's say this is x component, let's say this is y component. Okay, this is x component, this is y, actually x-axis, this is y-axis. Okay, this is 50 degree, and this angle between this force, let's say this force is equal to 100 Newton, and with the x, this is making, let's say 40 degree. Okay, with x this is 40 degree. Maybe it's better to use a different color. With x it's 40 degree. Okay, so this is going to be our fxy. This is y, this is x, and we are going to have the y component like this. This is going to be our fy component, and this is going to be our fx component. It's easy to find the z component, because to find the z component we can take this triangle separately. Like, we can form a triangle like this. The angle of this triangle is going to be 90 degree, and if we draw this triangle separately like this, okay, this is making 50 degree, and this is 100 Newton, and this is going to be our fz, and this is our fxy. Okay, to find the fz, you can see this is sine 50 because opposite over hypotenuse. So sine 50 is equal to fz over 100. Therefore fz is going to be equal to 100 sine 50. Therefore the z component is going to be equal to 100 sine 50, gives us 76.6 Newton. So the z component is going to be 76.6. But to find the xy component, first we have to find out what is fxy is. Then only we can apply cos 50 and sine 50 to find out the xy components. Now this is our fxy, right? So this is going to be cos 50, because you can see this is adjacent over hypotenuse. If we write cos theta, this is going to be cos 50 is equal to fxy divided by 100. Therefore fxy is going to be equal to 100 cos 50, and if you calculate 100 cos 50, that's going to give you 64.28 Newton. So this is why fxy. Now after we find out fxy, it's easier to find x component and y component, because we have the force that is making 64.28 Newton. Like, this force fxy is equal to 64.28 Newton, and we know the angle with the x component, and we know the angle with the x component, that is 40 degree. So we can directly find the xy component. Okay, And to find the x component, we use the cos theta, because you know that for this one, x is adjacent, right? If you take this angle, let's draw this one. It's better to draw this one separately. Okay, here we have the y component, and this is x component. This is our fxy, and this is our fy, and this is our fx, and this is our fxy. Okay, the angle is 40°, and we found out this value, that is 64.28 Newton. And if this is fx, this is also fx, and this is fy. And you can see, if we use cos theta, cos 40°, cos is adjacent over hypotenuse, so fx over fxy. So this one, fx is going to be fxy cos 40. We know the fxy, so fx is going to be 64.28 cos 40. And if you calculate this one, you're going to get 44.24 Newton. Okay, now we can find the y component. To find the y component, you can use the sine theta, because opposite over hypotenuse. Okay, let's use that one right here. Sine 40 is equal to, opposite is fy divided by fxy. So fy is going to be fxy sine 40. Fxy is 64.28 Newton multiplied by sine 40, and that's going to give us 43.32 Newton. Okay, now we have everything. We can write our component form. So the component form for this force 100 Newton is going to be equivalent to 44.24 in the I direction plus 43.32 in the j direction, and also we have 76.6 in the k direction, and that's going to be the component form for this vector. And that's how we do this kind of things. I hope this helps. Thanks for watching.